The principle of brushless motor that I didn't understand until graduation. If my teacher had taught me the principle of brushless motor like this when I was in school, I might have entered Harvard. Compared with the brushed motors, it has the advantages of low noise, low energy consumption, high safety, and low maintenance costs. So it has a wider range of applications. Before we talk about brush motors said, if we wrap a few coils of insulated wire on a metal bolt and then electrify the wire, the bolt becomes a piece of electromagnet. It and permanent magnets have the same properties. Close to each other will be opposites attract the same pole repel, and when changing the direction of the current, the polarity of the electromagnet will also change accordingly. In order to continuously change the direction of the current so that the electromagnet can rotate continuously through the interaction of the magnets and eventually introduce the brush, which is the brush motor. Understanding this principle, let's look at the brushless motor. Brush motor because the brush has friction, so the noise, loss, friction, fire safety is poor. Then we simply remove the brushes directly, so that the electromagnet is fixed. Instead of letting the permanent magnets not connected to the wire rotation is not enough. As shown in the figure, the 3 colored coil sets in the motor are actually 3 electromagnets. When one of the coils is energized, it is an electromagnet and possesses magnetism. In order to understand, we label each of the 3 sets of coils with the serial number. Because opposites attract and opposites repel, the permanent magnet is attracted to rotate to the position of coil 1. Then coil 1 is de-energized, coil 2 is energized, and the permanent magnet will continue to be attracted to rotate. Then coil 2 is de-energized, and coil 3 is energized, and when it rotates to coil 3, coil 1 is energized. But at this point, because the polarity of the permanent magnet is different, the current to coil 1 is going to be in a different direction and then continue to rotate attractively. It's like dropping a carrot you like to eat in front of you and attracting you to keep running. But this is not efficient. The rotation is not smooth. Then we can give 2 sets of coils energized at the same time, and then the permanent magnet will be 2 coils of a push and a pull, which is like again behind you put a wild dog chasing you, greatly improving the power of the motor. But how does the motor know when it is energizing and de-energizing which coil as well as controlling the direction of the current? It's actually through this Hall sensor that detects the exact position of the rotor magnets, which is then passed on to an electronic controller that determines which coil to excite to maintain rotational motion in the correct order of excitation. The principle here is more complex, we will not overstate. You only need to know that the control process is regular and computer-controlled on the line. Thanks for watching, like, comment, share, and subscribe.